Welcome to the deep dive. Today we're really getting into something fundamental, civil engineering.
Right.
Not just the roads and bridges, though. We're talking the big picture. The huge economic engine it represents, and, well, its environmental footprint, too.
Exactly. The stuff that literally shapes the world around us.
Think of this as getting, the essential grasp of what's going on beneath the surface.
And we've got some pretty compelling data to look at. We'll be digging into the 2024 U.S. Census figures on new infrastructure construction,
Okay.
and also a 2021 publication from the University of Oxford that focuses specifically on greenhouse gas emissions.
So, two key sources.
Right. And our mission really is to pull out the most crucial insights from these so you get a clear view of the sheer scale and, frankly, the implications of civil engineering right now.
Okay, scale. Let's jump right in there because, wow, in 2023 alone, the U.S. put an estimated $1.98 trillion into new civil engineering infrastructure.
Trillion with a T.
Yeah, $1.98 trillion. It's one of those numbers that's so big, it's almost abstract, isn't it? Hard to really feel what it means.
It really is. And, it represents this fundamental need we have. Upgrades, expansions, all to support our economy, our society.
Sure.
But it's also a massive opportunity, isn't it? And a challenge, too. How do we make sure these huge investments are, well, sustainable?
Exactly. Okay, let's try to make that $1.98 trillion a bit more tangible.
Good idea.
Imagine you had to pay it off $1 every single second, nonstop.
Yeah.
So to pay off $1 million like that takes about 12 days.
12 days, right. Manageable, sort of?
Ish. Now scale up to $1 billion. Still paying $1 a second.
Okay.
You're looking at roughly 32 years.
32 years. Wow. Okay, that's starting to feel significant.
Right. Now, a trillion, this word just gets kind of nuts.
Uh-huh.
Paying off $1 trillion at $1 per second would take about 64,000 years.
64,000 years.
Yeah. So the $1.98 trillion we're actually talking about,
Yeah.
we're looking at almost 128,000 years paying constantly, dollar by dollar.
That's it. I mean, it's just mind-boggling, isn't it?
It really is. The sheer financial weight we're dealing with here.
It absolutely underscores the monumental economic footprint of this whole sector.
For sure.
And this level of spending, it's directly tied to our environmental impact, which is, where that Oxford study comes in. It gives us some really crucial insights there.
Okay, right. Good transition. Let's switch gears then and unpack the environmental side.
Sounds good.
This 2021 Oxford study, it took a really wide look, didn't it, at greenhouse gas emissions across all the key civil engineering sectors.
It did. So things like energy production, our transport systems, water, waste management, digital communications, even buildings. Basically all the infrastructure.
And what did they find? What's the headline number?
Well, what's really striking is just how dominant these sectors are for emissions. Globally, they account for, get this, 79% of all greenhouse gas emissions.
79%. Wow.
Yeah, almost 80%. It's a huge slice of the pie.
That really makes you stop and think, doesn't it?
Yeah.
79%. So within that number, where are the biggest chunks coming from?
Okay, so the major contributors globally are energy production, that's about 37%.
Okay, the biggest.
Then transportation, that's around 16%.
16.
And buildings, surprisingly big too, at 17%.
Buildings, 17%.
Huh. And it's important, like you said, these are global figures. It gives us that worldwide picture.
Right, global. So if civil engineering is behind such a massive chunk of emissions, are there specific areas within it where maybe even small changes could have a really big positive impact?
That's exactly the right question. I mean, that's what we need to be thinking about. And when you connect it back to that huge economic investment we were just talking about.
Well, $1.98 trillion.
Yeah, it becomes really clear you can't look at these things separately. The economic decisions, the environmental consequences, they're completely intertwined.
What we build today, how we build it, it locks in things for the future, environmentally speaking.
Profoundly. And for a long, long time.
Which naturally brings us to thinking about that future. The Oxford study also looked ahead, right, at the costs of trying to shift things, become more sustainable by, say, 2050.
It did. And it's a pretty substantial shift they're talking about. They estimate that moving towards sustainability will affect something like 88% of costs across all these civil engineering sectors.
88%. So sustainability isn't just a nice idea, it's becoming a major economic factor.
Absolutely. It's rapidly becoming an economic reality. You can't ignore it.
And how do those costs break down? Is it spread evenly?
No, not at all. The distribution is actually quite revealing. For instance, things like waste management and digital communications, they're projected to have less than 1% of these sustainability-related costs. Pretty small.
Okay, minor players in the cost sense.
Right. But then you look at buildings, they're looking at around 22% of the costs.
22% for buildings.
And water infrastructure, this one's huge, 54%.
54%.
Yeah.
More than half the costs are tied up in making water systems sustainable.
That's what the projections suggest. It really highlights where significant investment is needed. Think about it like renovating your house for energy efficiency.
Great.
Swapping out light bulbs is pretty cheap, right? That's maybe like the waste management bit.
Right.
But putting in a whole new super efficient heating system or solar panels, that's a much bigger investment. That's more like the water infrastructure challenge.
That's a great analogy. Makes sense. Wow, 54% for water. That's a key takeaway right there.
Definitely.
And it doesn't stop at just the ongoing costs, does it? They also tried to estimate the upfront investment needed just to make the transition in the first place, say through 2040.
That's right. And again, the figures are, well, they're massive.
Brace ourselves.
Pretty much.
Yeah.
For the energy sector alone, the estimate is $28 trillion needed for this transition.
28 trillion.
For energy.
And for transportation, it's even bigger. An estimated $50 trillion.
$50 trillion for transportation. $50 trillion. These aren't small tweaks we're talking about. It's a fundamental transformation of how we approach building and running our infrastructure.
So when we say sustainable strategies for transport, what does that actually mean? Electric cars.
That's a big part of it, yeah. Building out the charging infrastructure. But it's also things like major investments in public transit, making that more viable, more efficient, and finding better ways to move freight around.
Okay, so let's try and sort of nail this down for everyone listening. Why does all this matter to you?
Right.
Well, first, we're talking about an annual economic investment in the U.S. alone that's nearly $2 trillion. Money that shapes everything.
Affects jobs, the economy, your daily life.
Second, this sector is responsible for the vast majority, nearly 80% globally, of the greenhouse gases driving climate change.
A huge environmental footprint.
And third, shifting towards sustainability. It's not just good for the planet, it's going to involve trillions and trillions of dollars in future costs and new investments.
Which does make you think, doesn't it? About the long-term environmental impact of all that money we're spending right now.
Exactly. Are we spending it wisely? Are we building problems or solutions?
Precisely. And this really brings up a crucial point. What's the role here? For civil engineers, yes, but really for all of us. In navigating this really complex situation, the data, it just screams opportunity, doesn't it? But also a huge amount of work ahead, finding those innovative, sustainable solutions for the very foundations of our society.
So wrapping this up for you, what we've really uncovered today is, first, the almost unimaginable financial scale of civil engineering.
Trillions every year.
And second, its undeniable massive impact on our global environment through those greenhouse gas emissions.
Almost 80%.
These aren't just numbers on a page. They're, fundamental forces shaping the world you live in.
Yeah, absolutely. And that brings us to maybe a final thought for you to chew on. Given these huge figures, the trillions being spent, the massive environmental footprint, where do you think the most crucial leverage points are? Which areas within civil engineering offer the biggest bang for the buck, so to speak, if we apply innovative, sustainable approaches? Where could we make the biggest difference for the future? It really forces you to think about how tightly connected everything is, the stuff we build, our economy, and, well, the health of the planet itself.